Hello, today I'm going to be presenting to you the Beats by Da Vinci presentation. First, I'll start off by explaining the four main components of a speaker. They are the voice coil, magnet, diaphragm, and terminals, in that exact order. The voice coil works as an electromagnet in a speaker by becoming magnetized as current flows through it. The permanent magnet and the voice coil are the two most essential parts to the conversion of vibrations to sound waves. The voice coil and permanent magnet's movement causes the diaphragm to move, which leads to vibrations becoming sound waves. The terminals in a speaker connect to the power source and provide the voice coil and wire with current. This is why the wire needs to be coiled. The wire in a speaker needs to be coiled because once the current is flowing through the wire, coils can create an oscillating magnetic field and overall strengthening the wire's magnetic field. In order to find the direction of this magnetic field, you can use the right-hand rule. The right-hand rule allows you to use the direction of current, represented by the thumb on your right hand, to find the direction of magnetic field. If you know the direction of current in the wire, you point your thumb in that direction. If the tips of your fingers are facing towards you, the magnetic field of the wire is going out of the paper. If your fingertips are facing away from you, the wire's magnetic field is going into the paper. This is why voice coils vibrate. Voice coils vibrate because the magnets, permanent and temporary, are being repeatedly repelled and attracted. This causes vibrations in the wire since it is being pulled back and forth. The back and forth movement of the wire presses and pulls on the diaphragm of the speaker, which leads to vibrations in the voice coil. This creates a wave of compressions and rarefactions by which sound is propagated in an elastic medium such as air. Put in simpler terms, the now sound waves then exit the diaphragm. Here's an explanation of why alternating current is needed instead of direct current. Alternating current is an electric current that periodically reverses direction, in contrast to direct current, which flows only in one direction. The abbreviations AC and DC are often used to mean simply alternating and direct, as when they modify current or voltage. When a speaker has alternating current, the dynamic of the magnets within changes periodically. Electric current is changing direction, therefore the temporary magnet is constantly alternating from its north to south pole. Meanwhile, the permanent magnet is continuous and remains facing the temporary magnet, with either its north or south pole, not both. This makes it so that the two magnets are being repelled and attracted. Here's how vibrations turn into what we perceive as sound. Sound waves are a transfer of energy caused by something vibrating. A real-life example of vibrations creating sound waves could be the wave, usually done by fans to cheer their team on in a stadium. Thousands of people are waving their hands in the air in sync, vibrating the air molecules around them. The energy leaving creates sound waves. In a speaker, the diaphragm is vibrating, which sends out energy and once again vibrates the air, a medium around them. Here's an explanation of results from prototyping. Before we began prototyping, we began by investigating the differences in a headphone made of different gauge wire. We found that the 26 gauge wire, also the thickest wire to choose from, gave the clearest and loudest sound waves. This is because the thicker the wire was, the least resistance it had. The least resistance, the easier and better it is for current to flow through. We also investigated how the number of coils in our voice coil affected the outcome. Our group found that 40 coils, which was the largest amount of coils we tested, was the loudest and second clearest of all trials. This is because the more coils added, the stronger our magnetic field became, which meant stronger vibrations and therefore louder sounds. At the same time, the vibrations were a little too much and the outcome was slightly distorted. We also tested 4 different materials for our diaphragm/cone to see what would be the best choice for our prototype. We found that the plastic cup worked the best as the diaphragm. The plastic cup, although having the largest mass of 6.15 grams, was also the strongest cup. The styrofoam and paper cups were both lightweight but were soft and would not react to the vibrations passed on by the magnets well. This is what sound waves look like and how they can change with loudness and pitch. Sound waves look like hills that are attached to each other, creating small valleys in between. A sound wave's amplitude is the distance between the top of the hill to halfway down the hill, in a sound wave known as crest to node. A sound wave's wavelength is the distance between the top of one hill to the top of the next, in a sound wave known as crest to crest. When a sound becomes louder, the amplitude increases. which increases the sound wave's overall height, amplitude times 2. When a sound becomes quieter, amplitude and height decrease. When a sound has a higher pitch, its wavelength decreases, which increases its frequency. When a sound has a lower pitch, its wavelength increases, which decreases frequency. Thank you for listening.